Okay, so chapter 14 is titled Working Drawings. So working drawings are going to be a set of drawings that are going to give us all the information about not only how to put the parts together, but what are the details of each one of the parts that go into that final assembly. Now, working drawings are a little different for different industries. So this book is written for architectural industry, construction industry, if you're in the electrical type of an atmosphere, but we're mechanical. So our drawings are going to look a little bit different, but they really, when we talk about working drawings, they really serve the same purpose no matter what industry we're in. It's a matter of showing now how all the individual pieces go together in relationship to one another to complete a project, complete an assembly, whatever it might be. Now, in this case, this obviously is an architectural drawing of, placement of furniture, in what looks like to be maybe an office or a school or something like that. Okay. And it's, properly sizing all of those items, but then also putting things and making sure that we have enough of. In the mechanical world, we're going to see assemblies that are going to look similar to what we have here. You'll notice that we have two proper, if you would, front and side views of whatever this is. It looks like it's an air brake assembly. Okay. These are our front and side views, but then we have a couple of like perspective views or isometric views. And you'll notice that couple things. We can see all of the individual parts in relationship to one another. Additionally, we have a list of parts. If I zoom in here, you'll notice that there's an item number. This item number is going to correspond to the balloon. Okay, so we'll find, like, for instance, item number 1, we're going to find balloon number 1, and that's pointing to a piece. And that piece then tells us how many of it there are, what its part number would be, and then what it's actually called. Okay. Now, in an isometric view like this gives us a little bit, I don't know if you would, a nicer perspective of where those pieces are in relationship to one another, as opposed to sometimes in a standard view like this. We're going to practice in mechanical design both. When we're in AutoCAD here, we're going to focus on the front and the right side view, because in the AutoCAD we only are working with 2D parts. We don't have kind of that isometric model created. When we get into parametric modeling in Creo, then we're going to have this opportunity to utilize assemblies like this and be able to show parts in their isometric view, which gives clarity to the person who's, kind of trying to interpret what's going on. Now, as you go down the list here, you're going to notice that there are 31 unique parts. And then they have their quantity, their corresponding quantity associated with them, as well as their part number, and then a description. This box in the bottom left-hand corner is called a bill of material, or a BOM, or a BOM. You'll sometimes hear it referred to. Okay. And that is going to be, like I said earlier, it gives us the exactly where that piece is, what it is, and how many there are. Okay. Now, this bill of material then is also used in the company, for instance, to order parts. Okay. So again, you are the hub of the good information that needs to get here. So it's important that you're accurate with part numbers, you're accurate with descriptions, you're accurate with quantities, because this is the document that other things are going to refer to in order to get the proper, pieces so that this assembly can be made. Additionally, you're going to notice that on this particular assembly drawing, there may be instructions for assembly that are specific to that. Okay. You as the designer would know that information. We're going to probably not be adding those things in our instance. We're just going to show the pieces, the balloons, and we're going to be making bills of material using our standard title block. If there are any revisions, notice they're up here as well. Okay, we talked briefly, we looked at revisions just earlier today. So this is going to be more of the type of assembly that you will be creating for the projects that we look at. Now, as we go forward here, here's another type of an assembly. Now, this one looks like it was a little bit older. Probably, I don't even think it was maybe created in CAD. I don't know, maybe it was. Here you'll notice that there is a section view here so that we can see internal pieces. Okay, sometimes that has to happen. Maybe there's a cover that's all the way around it and the parts are on the inside, but they're all part of the same assembly, now we've got to be able to look inside of there. So we're going to use some of those techniques that we've practiced on those individual parts. We can apply them to assemblies here as well. And that's what you see here. We have a section view that is going through so that we can see internal gears and shafts and keys and any other you know, types of components that are going to be hidden, you know, inside of, you know, a guard or a cover of some sort. Notice here, in this case, our bill of material is going to be starting with the header at the bottom. So this is going to be the item number going up on the left. Then they have their, in this case, the part name, the description, they have the required quantity, and then they have the material. So a little bit different format on the bill of material. That is going to be specific, that standard, if you would, is going to be specific to the company. It's going to be specific to the company, how they want it. In this case, and this is the type that I'm going to have you guys do, and the type that I use out in industry, the headings were at the bottom, right above the title block, so that in the case that we would want to add parts to the top of it, now we've got room to just go up. Okay. If you do that with a top down, then you kind of have to make space for it, push it up, and you have to do a little bit more, you know, making room. So this is more the kind that you see more often, if you would, for that very reason. Different types of assembly drawings. So here we've got detail assemblies and layouts, general assemblies, detail assemblies, working drawing assemblies. That's going to be the type that we're going to be using here. That is most common in industry. Sometimes you can have detail assemblies, and what that means is that you'll detail a part in an assembly view. That's not great practice because, again, especially if it's an individual part, you want to have its own part number so it can be made. You can create the quantities and then you can bring it together. So it's always better to do that detail work on its own drawing, in its own part number, in its own file. So a detail drawing, referred to as a detail drawing, is going to be the individual pieces. So the 3 drawings that we were looking at earlier today, those are the 3 details for that shaft support subassembly that we're going to be creating in chapter 12 in our AutoCAD book. Okay. So the 3 details would have been those 3 individual parts, and that's what we see here. Now, in this case, it looks like this part was created using modeling software like a Creo or SolidWorks. And what's cool about this is you can then have that option of putting a view of the model in an isometric view up in the corner. And then it also helps bring clarity to the other views that you have here. In AutoCAD, unfortunately, because we're not creating a 3D model, we don't have that. So we have to stick with our 3 views, but you get to look forward to doing that. Any notes, fill in your title block, all that kind of stuff. Okay, so that's a detail. Now, a subassembly is really just a smaller part of a larger assembly, meaning sometimes we can put maybe a cluster of parts together that are then going to go into a larger assembly. Okay, so that's called a sub-assembly. So it's a smaller part of where we can kind of assemble this over here on the side before it goes together in the final assembly. So here, a sub-assembly is, you know, really what we were, you know, kind of referring to. Not to the standard that we're going to be using, the ANSI standard, but you can see how the parts are all together. There is a partial section view here, so we can see internal parts. They're pointing to the items, but we would be relying on balloons and then a bill of material, you know, to actually give our listing. But that's one version. Now, as we look at the identification of the parts in an assembly drawing, we are going to be using the same types of standards that we've been looking, or that we've been using and applying with text. The text all has to be the same size. So if on your title block, you pull in your title block, the text is going to be its, you know, whatever size, 1/8 of an inch. If you pull that title block in 3 times, then all you have to do, if you have everything set up properly, all you have to do is go to the dimension tab for the dimension style manager and go to the fit tab and then just change the scale to match whatever it was that you brought your border in at. Okay, if that sounds foreign to any of you, then you're gonna want to you know, follow along with what I have a little bit later in this session. But now all you have to do is all of your text is going to be the same size. Same thing with your bill of material, all has to be the same size. So, so don't make the executive decision and say, oh, I think it looks better with this, that, or the other. No. We're following a standard. All the text has to be the same height. Parts list or bill of material. We've kind of talked about this already. The item number is going to correspond to the balloon call out, the quantity, how many of those need to come together, the part number. Now, this is also going to equate when you get out in industry, and we'll start practicing this a little bit later too. Part number is going to be the file number that you save it as. We've been, just based on just how our books are structured, we've been calling our files the names that they are. So it's been like, base plate and collar and bearing, but really that's its description. Your part number is really going to be the file that you save it as. Okay. And then that way, I mean, you could have a number of different collar names, but they all would have different part numbers. Okay. Assembly sections. Assembly sections. All right. So you'll notice here when we do assembly sections, any different parts that are touching one another, their hatching has to go in opposite directions so that you can see that it's a different part. You would not put all the hatching going in one direction. Okay. Then it looks like it's a continuous part with like lines, and it's not correct. You'll also notice that when they show these parts together, and this is where this book sometimes violates some standards. You'll notice that there's this, I would call this a key, this part right here. This is what we call the innermost material. We do not hatch innermost material. So that key, this should remain open, okay, by the standard. So sorry that it's there. I'll make sure that as I'm, kind of showing you things and they come together, I'll reiterate that, but that's a bad example. Additionally, you'll notice that and they did this correctly, you do not hatch any fasteners. Okay, so if something is holding something together, we see them as their view like that. Okay, we do not hatch fasteners at all. Okay, so that looks good. And I think I'm at the end. A lot of the practice we're going to get with assemblies and putting them together properly is going to be in the practice that we do in chapter 12 of AutoCAD, but then also your final project, which I'll talk about a little bit later today. Okay, so that's just an introduction. What I'm going to do is I'm going to stop recording here, and then we will take a break.